So this question talks about Fibonacci sequence. Now we've got to remember that Fibonacci sequence has the general form that you take the two previous terms and then add those together to get the next term. So if A and B were your first terms, then your next term would be A plus B, and then your next term would be A plus 2B, and then your next term would be 2A plus 3B, and so on. So you're adding the previous two terms to get the next term. So something plus 5 must have given us 9, so that's got to be 4. 5 plus 9 would give us 14. 9 plus 14 would give us 23. 14 plus 23 gives us 37. 23 plus 37 gives us 60. So fill in the missing numbers, then that's the idea. That the Fibonacci sequence is the previous two terms give you the next term. A quadratic sequence has an nth term rule. What is the seventh term? Well, what we need to remember about sequences is that we use this letter n to stand for the term position. So the seventh term, n, will be equal to 7. And when we've got an nth term rule given to us, what the question is asking us is to substitute for n the value of the term number. So in this case 7 squared, take away 3 bracket 7. Just notice, I think this technique helps limit mistakes. Always substitute by putting a bracket around, and then calculators tend not to make as many mistakes. So 4 times bracket 7 bracket squared, take away 3 times bracket 7 close bracket equals, so 175. So that will be the seventh term of this particular quadratic sequence. This question talks about finding an expression for the angle ADB. So we want the angle ADB, so ADB. So that's this angle here. And we want it in terms of x. Explain your working, so in other words, we've got to give reasons for everything that we do. Now what we're going to recognise about this question is we've got parallel lines, and the question's talking about angles. So straight away when we see parallel lines and angles, we should be thinking of alternate angles are equal. Corresponding angles and co-interior angles trapped by the parallel lines and the line crossing the parallels always add to 180. So co-interior angles add to 180 degrees. So we have all those facts that we know about angles when we're involving parallel lines and lines crossing them, and that allows us then to say that this angle here is also going to be x, and then we give the reason. Alternate angles are equal. We can see that it forms the kind of Z picture backwards. Excuse me. Okay, so we then got to start thinking about what else do we know about this shape. Well, because they've told us that the two dashes there, they're telling us that these two lines, DA and DB, are the same, then we have an isosceles triangle, and therefore the base angles in an isosceles triangle are equal. So again, we've got to give reasons for why we do things. So base angles in an isosceles triangle are equal. Now we can do this around the picture. You could write out all the language. You could say angle DBA equals angle DAB, isosceles, and so forth, but you can draw arrows to things and point out why you're doing it. And then we can finish off, because we know that angles in a triangle are to 180, and the question wanted angle ADB, so basically we're going to say angle ADB equals 180 degrees minus 2x, and the reason we're going to do that is we're going to say angles in a triangle add to 180 degrees. Okay, so that's how that question would be done. It wanted it in terms of x, and that's all that means is write something with an x in it. and we've gone through and reasoned why we've got all the particular parts of the answer that we have, given the full reasons, so we've explained our working, and that's how that question was expected to be answered. Okay, so standard form. So we've got to remember that this is a calculator paper, so we've got to remember there's a standard form key in our calculators, which is on this particular calculator is this one here. It's got the times 10 to the power of already written in for us. So firstly, though, it wants you to write this as an ordinary number. Well, we must remember that the times 10 to the power of 4 means that the 6.4 moves up 4 places. So that was units or ones. So it's going to move at 4 places, so it's going to go to the tens, the hundreds, the thousands, the 10,000s. So it becomes 64,000. Okay, so it started there in the ones column, the units column, and it moved over 4 places. Okay. This one is going to be written in standard form, so we've got to recognise that standard form numbers always look like that, where a has got to be less than 10 but greater than or equal to 1, and n is an integer, a whole number. So 3.9, and that means this was the 10 to the power of 0 column, the units column, the 1 column. Then it goes 10 to the minus 1, 10 to the negative 2, 10 to the negative 3. So that's where the 3 is. So it's going to be times 10 to the power of negative 3. 3 is in the thousandths column, which is 10 to the power of negative 3. Write this in standard form. Well, we've got to remember that standard form has to be, like we said here, between 1 and 10. This is 0.25, so we have to change that to 2.5, but that means that was 2.5 times 10 to the power of negative 1. We'll still times it by the 10 to the power of 7, and then we recognise that when we're times it with the same base, then the powers can be added. So 7 take away 1 is 6, so the answer here will be 2.5 times 10 to the power of 6. Okay, so this question wants us to work out a calculation. It's a calculator paper, so we're literally going to type it in using the standard form key. So 3.4, we press our standard form key, that's the times 10 bit done. All we've got to do is tell it the power we want, so power 5, and we're dividing by 1.79, standard form key, for the times 10 bit, and we want negative 2. Just remember to use the negative key, not the minus key. And we press equals, so it gave us an answer of 1899413, 0.41. That's the ordinary number. Now we need that back in standard form. So we've got lots of ways of doing this. We could put our calculator back into, let's do that calculation again. So 3.4 power 5 divided by 1.79 power negative 2. Okay, and shift setup, and we've got a scientific mode 7, say 9 decimal places, right? Okay, so using our standard form mode, we can then get this back into standard form, which is telling us it's going to be 1.899 times 10 to the power of 7. So that's going to be the answer there. So we can get our calculator to work in standard form mode by changing the setup to standard form. I'm going to put it back into ordinary mode there because I need it back in normal mode for other calculations, normal 1. And we could also check that by recognising that that would be 10 to the power of 0, 10 to the power of 1, and then we'd have gone 2, 3, 4, 5, 6, 7. So it would have been not 7, or we could move it down 7 places to get to the decimal point. There's loads of different ways of getting that back into standard form. Okay, so learn your standard form key on your calculator, guys, because pretty sure it'll be there in your exam somewhere. Okay, so question 21 goes on and says solve this inequality. So solving means rearrange to get the letter on its own. So move things by doing the opposite operations. So we end up with 4y's, it's got to be less than or equal to 30, and then we divide by 4 to find that y has got to be less than or equal to 7.5. So y less than or equal to 7.5. The key to remember when you're solving inequalities is that you must keep the inequality signs and just keep moving things around until you get the letter on its own. If the letter's negative, then move it to the other side of the inequality to make it positive, and then deal with the rest of the question. Okay, so we've got a geometric sequence. Now geometric means that there's a multiplying factor. So a simple geometric sequence would be 1, 2, 4, 8, because you're timesing by 2 every time. So geometric sequence is where there's a multiplying factor between each term, and the multiplying factor is called the common ratio, which means it's the same all the time. So when we can look at this one, we can see that the difference between 2a squared and a is when we do the division, we can get the ratio. A squared divided by a is a, and 2 divided by 1 is 2. So it looks like we're multiplying by 2a, so let's just check that with the next one. So 4a cubed divided by 2a squared. So 4 divided by 2 is 2, a cubed divided by a squared is a. Yep, so we're multiplying by 2a. So when it says what is the next term of the sequence, we need to do 8a to the power of 4 times 2a, which gives us 16a to the power of 5. So that's our next term. Okay, so question 23 goes on about calculating a percent as an answer. And to me, whenever you see a percent as an answer, you're always thinking of a fraction times 100. And the fraction will be comes from the question when you read it. So what's the percentage increase in the price of rice? So we need the original price of rice, which was £1.08, and we need the increase. So it'll be the 134 take away the 108. Okay, so fraction key, 1.34 take away 1.08 over 1.08, come away from the fraction, times 100 equals, and change that into 24.1%. So 24.1%. Okay, so when you're doing an answer as a percent, then as I say, the classic way of thinking of those is fraction times 100. And the fraction just comes from reading the information and going through what it actually wanted. Remember the bottom there is always the original amount. Okay, so that's an example of percent. Okay, so this question involves a cylinder, and basically we should be asking ourselves, what do we know about a cylinder? So we know the volume is the cross-section area, pi r squared, so circle, pi r squared, times the length of the shape, and for a cylinder we tend to call it the height of the shape, although the cylinders also can be the other way around. It says work out the volume, so that's fine. So we write down the formula, fill in the numbers we know. Well, they told us the radius of this cylinder was 4, and they told us the height of it was 10, and we're squaring the radius. So again, it's a calculated question. So find our pi key, shift pi, times 4 squared times 10. Change it into a decimal, so 502.6548, and then we realise the question wanted the answer to 3 significant figures. So we just got to remember that 3 significant figures means find the first non-zero digits, so that's the first significant figure. 1, 2, 3, so we're basically cutting the number there. 6 is 5/10 or more, so it's going to move the units up by 1, so the answer here will be 503. Okay. The question then goes on and talks about the cylinder is made from wood, the density, so it's mentioned the word density, so density is equal to mass over volume, so one of those triangles, 3-letter formula, so DMV. It says work out the mass of the cylinder, so when we cover up mass we can see density and volume next to each other, so the mass is equal to the density times the volume. Again, we can see that works because if the V's got to come across here, then we're timesing because it said divide here, do the opposite to move things. So we end up with the mass is equal to the density times the volume. The density we've been told is 0.6. The volume we worked out the previous question. So we can use the 502.6548. and we've got that answer still on our calculator, so we can just times that by 0.6 equals, so 301.59, 301.59. Excuse me. We wanted the answer to 3 significant figures, so first significant figure, first non-zero digit, and then count along, so 1, 2, 3. So we're going to cut that, so it's going to be 302 grams. Okay, so that's a quick recap of volumes of cylinders and how to find the density of an object using the formula density equals mass over volume. All these formulas, remember guys, you've got to remember, so make sure you're practicing them. So this question talks about a diagram representing a garden, diagram drawn to a scale, so that means it's accurate, so we're going to use equipment, so it's accurate. So we're going to use compasses, or a pair of compasses shall we say, and a ruler. Trees to be planted nearest A, B and AC, right, so it's a loci question, isn't it, because it's asking us to construct according to given rules and show a region or show a point. So nearer to AB than AC, well, if we think what that looks like, it looks like this, AB to AC, and therefore we create an angle, and so we should be shouting out draw an angle bisector, because we need to show the points that are nearer to one line than another, so we need to be showing the middle of the angle as the boundary, so we need an angle bisector. So get our compasses, again set your compasses up first. An angle bisector is where we draw an arc to cross through the two lines, and then where the arc has crossed through the two lines, we then draw an arc inside the shape, roughly where the middle of the angle is going to be, and then we draw the line across the garden, and that's going to be our boundary line. Now leave your construction lines on the question. So that's shown that bit, and then we've got to say within 5 meters of point A, well they've told us the scale is 1 centimeters to 1 meter. So we get our ruler, and because it's talking about a single point, then single point A, then we know that we're kind of drawing a circle around it, and the radius has got to be 5 centimeters. So again, always make sure your compasses are really tight before you walk into your exam, so get a screwdriver out and tighten them up. Okay, so that's 5. And so we've opened our compasses up 5 centimeters, and it says from point A, so our compass point goes on A, and we draw the boundary, and it says shade the region where the tree may be planted. So it needs to be nearer to AB, so that means it's got to be up here somewhere, and it got to be within 5 meters of point A. So in other words, they want us to shade in this bit here because it's saying it's got to be within 5 meters of point A. So that's what that question wanted. So loci, practice your compass constructions, angle bisector, perpendicular bisector, and so forth. So we've got another question here involving a shape, and again it's given us some rules. So it's going to be loci, and although they haven't given us a scale, we can assume that 1 centimeter is accurate. So it says more than 4 centimeters from point A, so again that means compasses open single point, so because it's mentioned a single point, then we draw a circle or part of a circle. So we're opening our compasses up 4 centimeters, again making sure our compasses are really tight. And it says from point A, and it then says closer to point C than B, so it's mentioned 2 points, C and B. That means we want the line in the middle, so as the boundary, so that we can be closer to point C, And when we want a line in the middle, then we draw what I classically call the fish picture. So in other words, we want the perpendicular bisector. Perpendicular bisector. Okay, so that means we find CB, we open our compasses up over half the distance between them. Well over halfway is usually a good way of thinking about it. And we draw roughly across the halfway point between them. And then from the other side we put it on B and we just join so we can see where we're doing. Put our 2 points down where the intersect point happened, and then draw, so to be closer to C than B. So okay, and then it's saying and more than 1 centimetre from the line DC. Well, when it talks about a single line, then we need to be 1 centimetre away all the time. So we're drawing a parallel line. So when it's got a single line mentioned in the question, it wants you to draw a parallel line. And what we tend to do with that is we get our ruler, and because it's 1 centimetre, then we basically draw 3 dashes so we can line our ruler up carefully. And it says from DC, so it's this bottom line here, and then we draw the line across. Okay, and then we read the conditions again so that we can shade the region that they wanted. So it says more than 4 centimetres from point A. So this was the 4 centimetre boundary line, so we need to be over here. It says closer to C than B, so that means we need to be closer to C than B, so we need to be down here below this halfway line. And more than 4 centimetres from point A. So basically it wants the region to be all of that bit there. Okay, and it has to be more than 1 centimetre, so it means the other side of the line. So that's how that question could be done. Again, loci, practice, perpendicular bisectors, angle bisectors, parallel lines, and drawing around a point is classically what they need you to draw to shade regions. Okay. So this question is a transformations question, so always make sure you've got some tracing paper available. And it says describe fully the single transformation that maps A to B. Right, okay, so when it says describe fully the single transformation, then we've got to remember there are 4 transformations. So we have a reflection, we have a rotation, we have a translation, we'll leave the vector, and we have an enlargement where shapes get bigger or smaller. Okay, so we can see from here that a rotation is definitely not happening. It's definitely not translation because it would be in the same orientation, so A was pointing downwards, so it would be over here, something like that if it was a translation. And it's nothing like an enlargement. Not a GCSE level, they don't do enlargement scale factor 1, so it's going to be a reflection. So we're definitely looking at a reflection, and it says describe fully, and it's worth 2 marks, so you're not going to get 2 marks just for saying the word reflection, so you have to decide where the line of reflection is. Now, we know that a line of reflection, there's 4 classic lines that you have to remember, and it looks like this is the line that does that. So this is the one where every coordinate is the same, so y equals x. So it's a reflection across the line, y equals x. So when you're practicing reflections, remember there are 4 lines that you need to be familiar with. There's the vertical lines where they're always x equals a number, so x equals 6 if that's going through 6. There's the horizontal lines where it's y equals a number, so if this was 3, then it'd be y equals 3. There are the diagonal lines that classically y equals x, and then there's the opposite direction y equals negative x. If they want to really push it, they could ask you to do a reflection line, something like y equals 2x plus 1, so they can expect you to do y equals mx plus c lines as well. But basically reflections, you're looking for a mirror line. And if you want to check your mirror lines, remember your tracing paper helps as well. So if you get your tracing paper, if you've got your mirror line correct, then you should be able to just turn your tracing paper over, so reflect it over, line up your mirror line, and you should find, as this does, it goes over the shape that you've reflected to the image. Okay, so then it says on the grid, rotate the triangle 90 degrees anti-clockwise around the point negative 1, 1. So they've already marked it for us, but if they hadn't, then make sure you do mark the rotation point. It's 90 degrees anti-clockwise, so basically, and it's shape A. So we sketch shape A. We put a pencil point down, and we were facing north, so if we go anti-clockwise we'll be facing west, so we want the north line to face west, so it's gone there. And basically we must make sure then, just by lifting the tracing paper up, put the 3 corners, 3 vertices, just make sure it's right, yep, and then we get our ruler, and then we show it accurately. Okay, and they said label it triangle C, so obviously make sure you do label as the examiners want you to. So 90 degrees anti-clockwise, just check it. Yeah, our other check is to choose a corner, a vertex, and if that line is rotating it would go there, so 90 degrees, so that's fine as well. Okay, so that's a bit of a recap on transformations. Pretty sure there'll be a transformation question in your exam somewhere, whether it's paper 2 or paper 3, who knows. So do practice and learn those. So we'll just do one more, and this time we can see that we've got a large shape drawn on a grid, and the question when we read it says that we're going to translate this triangle by a vector of 8, negative 3. Now remember 8 on the top part of the vector means that we go right. If it was a negative we'd go left, and the negative 3 on the bottom here is telling us that we're going to go down 3. Okay, if it was a positive one it would tell us to go up. Alright, so we choose a vertex and we follow those instructions, so it's 8 right, 3 down. So if we choose this one here, so we're going to go, now the scale is 1, so you always look at the scale because it's important that you actually use the scale. So every square is 1, so that's fine. So 1, 2, 3, 4, 5, 6, 7, 8, and then down 3. 1, 2, 3. Okay, so the whole triangle moves. So it was 2, 4, 6 wide. So 2, 4, 6. Make sure it's exactly the same, congruent. 2, 4, 6. And it was 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Okay. And join it up to make the triangle. Okay. And then you check by using your tracing paper, because obviously you don't want to lose a mark from making a square error. And as the translation always produces a congruent shape, then when you put that over you should find it's identically the same. And then you could use your tracing paper to just check that you moved it correctly. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Seems to be okay. Okay, it says label it Q, so label it Q. Okay, so that was the translation done. It then says we've got to enlarge the triangle by a scale factor of 1/3. So a scale factor of 1/3 means we divide all lengths by 3. So our original triangle was 6 and 12. So our new triangle is going to be 2 and 4. So you've got to remember that. And it wants you to use centre 15, 6. So make sure we mark that. So 15, 6. So 15, 2, 4, 6. Now, when you're doing centre enlargement type questions, then the clue to this question is that we draw one of the construction lines. Now, we're going from P, so and basically you can either measure that and go a third of the length. So I can see that I've gone 2, 4, 6 diagonals. Click scale factor of a third, I'm just going to go 2 diagonals. Or I can count squares, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And if I third that, then it's 2 and 2. So I can see that I've gone 2 and 2. So either way, I can get to where my new shape's going to be. And we've already decided how big the shape has to be, because the original shape was 6 and 12, so our new shape will be a third of that, so you divide by 3, so it's 2 and 4. So it's going to be 4 up, 1, 2, 3, 4, and it's going to be 2 across. And our check is to draw another construction line, and we can see that, we can draw all of them really, but we can see that our check worked because it's all lined up, and they set to label that R. Okay, so that was an enlargement of scale factor of third, centre 15.6, and we did that by drawing the line at the centre point, and then drawing a construction line, and then making it a third as big by dividing by 3. So all the lengths got divided by 3. Okay, so that's a rundown of transformations.